Suppose you take a solution and add more solvent so the original mass of the solvent is doubled. You take this new solution and add more solute so that the original mass of the solute is doubled. What happens to the molality of the final solution compared to the original molality? Okay, so to start off, we remember that molality is moles per kilogram. So what we could do is do a test here and see if we double the kilograms as well as the mass of the solute, then we can see if which one of these cases is true, if it's or if we need to know more information. So we can start off by putting in some arbitrary values. So let's say we have, it says we have a mass of a solute, so 10 grams of some solute, and for simplicity we'll say that that has a molar mass of 1 gram per mole, so we can just flip that and say 1 mole per gram, and we want to keep this simple so that and we want moles in the top because we're going to have down here some volume, or some mass in kilograms. And so let's say we have down here 5 grams of our solvent. So up here we're going to have 10 moles per 5 grams, and we want it. We could leave it here and it would work out the same, but we want kilograms just to be totally accurate, and so we would have 1,000 grams per kilogram. So we can cancel these units. This is 2 times 1,000 is a 2,000 moles per kilogram, 2,000 molality. Okay, so let me switch my color here, and we can do one where we double the grams here of solute and solvent. So let me write that this is number 1. Number 2, we're going to double. So instead of 10 grams, we have 20 grams here, times again, it's the same compound or element, so our 1 mole per gram mass won't need to be changed in any way, so 1 mole per 1 gram. And on the bottom here we will have 10 grams instead of 5, sorry. And then that's going to equal, these are going to cancel, so this is going to be 2, so we're going to cancel this, so that's going to be 2 moles. I just canceled these zeros to be clear. 2 moles per gram, and again multiply by 1,000 grams per kilogram, and these will again cancel, and we will be left, number 2, the molality is 2 moles per kilogram. And keep in mind that the same procedure works if it asks for molarity, because we would have, if it was some gram value down here, then the mass of the solvent, we could do the same thing we did up here with say the density, sorry, not the molar mass, I should have said density of the solvent, and we could multiply by, say, whatever the inverse of whatever value it is. So say it was one 1 mole per, or sorry, 1 liter per, I don't know, however many grams, or 1 gram per 1 liter, or 2 grams per liter, or whatever it may be. And we could be left with liters down here instead of grams and eventually kilograms, and this would work out to find molarity, not just molality. So if it asks for molarity, the answer should be the same. So I wrote two, not 2,000. Whoops, 2,000 moles per kilogram. And so these two are equal, so our choice that we will select would be D. It is unchanged molality.